this is the original data, and then you can see the way that I linearized it is by just taking the log base 2 of x and the log base 2 of y. Today is Saturday, September 3rd, 2022. It is also day 412 of data science, and today I have some nonlinear data in a pandas data frame that I'm going to linearize. And the purpose for linearizing data is to use a linear regression model. And a linear regression model allows you to predict one variable in terms of another, which you could do with the equation if it's linear. And right now I have this data frame and I have these data values, which do not give me a linear equation. If I actually go and import Seaborn, which is my plotting library, I'll be able to see the scatter plot for the actual values. So I'll just plot in X and then I'll also plot in Y. And if I plot that or run that, I'll be able to see that the data for, or actually the graph for this data is not linear. And in order to linearize the data, I first have to know what the equation is, and I put it up here. It's y is equal to 1/2 x to the second power. So my base is 2, and that's what I need to know, because in order to linearize the data, I have to take the log base of y and the log base of x, and I would need to know what the base is, so it is 2. So now that I know that, I'm going to go down here, and I'm just going to create a new data frame, call it new, and set it equal to pd.dataframe. And then just put in, like, let's say the same values, it doesn't really matter. And then I'll do comma and then put in y. And after the colon is just going to be a new set of numbers, which I'm going to actually state above over here first. So what I'm going to do is I'm going to take in dfx, which was from the old data frame, and I'm going to do np.log, and then I'm going to put 2. And then just put it in parentheses. And in order to actually use NP, I'll have to import it. So import numpy as NP and set that as my X. So I'll set that equal to X. And then my Y, just change that to Y and then change this to Y. And then over here, I'll put in X, and then over here, I'll put in Y and run that. All right. And now if I do df new, I'll be able to see the new, what would you call it? The new values, the linearized values. So now instead of it being, let's look at the other one. Instead of it being 1 and 0.5, now it's 0 and -1. And now if I plot in the data, I'll do, let's say, SNS dot scatter plot, and then plot in df new, or instead of new, I should have probably say linear, and put in my X in there, and then again df linear, put in my y, and I'll just change that up there also. So let me put that in there. So run that, put that in here. All right, let me see what I did wrong. Is an invalid key. Forgot my bracket over here. Let's see. Oh, it's because I did an extra one at the end. All right. There we go. So now you can definitely see the linear relationship. And so just to kind of go back on what I did, I just took the log, right, of my x values, and I took the log base 2 of my y values, and I just created a new data frame and called it df linear, and that's what my plot is now. So these are the same values, except that they're logged. So the log of y is there and the log of x is there, and what that does, it just linearizes the data and it makes it linear. So now I'm actually able to use a linear regression model in order to predict my values. So to summarize, I started off with my power model, y is equal to 1/2 x squared. I linearized the data, and the way that I knew how to linearize the data is because the rule is that if it's a power model, and in order to linearize the data, you have to just take the log base of x and the log base of y. So I did that, and then it converted to a different type of equation, which is log base 2 y equals to -1 plus 2, which is the base, and then log 2x. All right, and then I saw my linear data. Now to kind of summarize a little bit more, I'm going to make a matplotlib figure, just plotting both graphs side by side just to compare. So I'll import matplotlib for that, which is just another plotting library. So matplotlib.pyplot as plt, and then I'll do plt.subplots, which is a function that gives me a figure, and I'll just set the fig size to be, let's see, 10 in width and 4 units in height. Run that, and that returns to me a figure with one axis, but one axis means like one graph, so that's why you only see one graph here. So in order to change how many graphs, I'll say n rows 1 because I want one row, but then I'll do n columns and set that to 2 because I want two graphs or two axes, and now I'll be able to see two axes, which is the same thing as two graphs. Now to actually access these variables or these objects, I have to set them equal to a variable. So I'll set the first one respectively figure, and then I'll do the second one, I'll do let's say graph 1 and graph 2 and set that equal there. But here's the problem, I can't just do this. I actually have to put these in parentheses, and then further, when it's in parentheses, I actually have to put the graphs or the axes that are within each row in their own parentheses. So anything inside these external parentheses, I can't even speak right now. This is like so confusing to say. So you have your external parentheses, which are just like purely syntax, but then each row that you have within your figure represents another pair of parentheses. So if I were to have another row, I would have to say, like, with another two graphs, I would do like graph 3 and then graph 4, and that's how I would set the variables equal to that. But I don't have another row, so I'm just gonna leave it like that. So what now? I forgot a comma. All right, run that, and then it should work. And now I'm able to access the figure, the graph, and the graph 2. So the graph 1, I want it to be my first, let's see, my first plot, which was over here. And I'll just put this in the same line over here. And then Seaborn has this parameter called AX, which stands for axes, and I can just set it equal to whichever graph I want. So I want it to be graph 1, so I'll set it equal to graph 1. And then I'll do the same for the linearized one. Paste that in there, and I'll set the axes of this graph to be graph 2. And now if I run that, I'll be able to see the graphs in their respective axes, which is pretty cool. Now I could also, let's see, I could do graph 1 and set the title for that. So I could say, okay, this is the original data, and then I'll be able to run that, see that, and then I can do the same thing for graph 2, and then just change that to graph 2 and say, let's say, linearized data, right? And that's pretty cool. And I could also change graph 2 set title, not set title, let's say set x label, and just say log base, or like log 2 of x, because that's what I did, that's the actual axes. And then graph 2 set y label, and just change that to y. And that really represents what I did over here. So you could see that this is the original data, and then you can see the way that I linearized it is by just taking the log base 2 of x and the log base 2 of y, and it became linear, which is pretty cool. And that's pretty much it for today. I'm gonna go now. Bye.